All right, we're going to pick up where I left off. I'm not starting over. So we're going to build those shapes that you're playing with now. It's easier to see them when we take a look at, I've got a Sketchpad demo that shows you how they're built. So this is just a, technically it's not a disk method, but it gets categorized under disk method. It's commonly called cross sections, because you're stacking a bunch of cross sections together and making a three-dimensional figure. So you should be able to calculate the volume of that bad boy. It's a real easy formula, and it's not bad math to do. The difficulty here is the visualization. If I give you, let's say, an equilateral triangle. Things getting crazy back there in the corner? What do we, Oops. It's all right. And don't forget to eat your dessert first tonight. I dare you. Okay. So when Mom puts dinner on the table and I go, yo, what's for dessert? Bust it out. But don't blame me. Okay, so, blah, 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 disk method, and a disk or washer, yeah, I don't care about it. Sketchpad, right here. Okay, let's look at this. Okay. I'm going to start with a circular base. You don't have to start with a circular base, and in fact, the first actual mathematical example I'm going to go through does not use a circular base, but we'll do a circular base to start because it's easier to tell. Okay, so I'm going to start with a circle, and you can see that those are all my cross sections, or an example of some of the cross sections. You would know those as representative rectangles, but we want to make this thing look a little 3D, so I'm going to drop it down like that. And in this case, actually, let's do that. That'll be easier to see. We're going to do squares here. So if I take one of the squares and I move it along the figure, you'll see as that figure moves down the shape, the square gets bigger until it hits its maximum shape, and then it shrinks back down to 0. And then it does it again. When it does that, it ends up building that three-dimensional figure that you've got flying around the room. You get that funky looking thing, which as far as I know doesn't have a name. So there's the solid, and then you see again that that comes from sliding that square inside and making a shape. Now, does it have to be a square? No. We could do the same thing. The second figure I have is an equilateral triangle, so there's the representative rectangles, flatten it out so it looks all 3D and cool. And then, oh no, wrong one. That's the one I want. So you got your equilateral triangle flying through there, and eventually it makes this solid, which is the second shape that's flying around there. Okay. So the method is pretty simple. Once we get to it, we can change two things in the problem. We can change the base. This circle is called the base. And then we can change the cross section. What is being stood up on that shape? Are we using squares? Are we using equilateral triangles? Are we using semicircles? Are we using cutouts of panda bears? Whatever it is you're using, you can create a three-dimensional figure. This, for instance, is still a circle, but instead of using a rectangle or an equilateral, or a square or an equilateral triangle, you can do it using an isosceles triangle, which gives you something that looks like that. So that's an isosceles right triangle, where you've got a right angle down here, and it makes that weird looking thingamajobber. Okay? So that's what we're going to do. Our job is not necessarily to draw those. If you can draw those, more power to you. Jasper? Can you draw those?
Yeah.
Good. Yeah. Well, he's an art guy, right?
Yeah.
Yeah. Okay. So that's going to be your homework tonight. Just draw three-dimensional representations of all those problems. As I mentioned, simple formula. There's the. Let's not worry about the bottom one now because it's just if you do it along a horizontal axis. But there it is. Find the area of the cross section and add up all the cross sections. That's all you need to do. It's just that simple. Well, it's a little trickier than that, but
Sounds excellent.
yeah. And then if we change it to horizontally, if you're going to sweep it horizontally, then you just do everything in terms of y, same formula. Okay. So the first example that we're going to do is this guy. We're going to take this base, and the base is generated by taking x equals y cubed and the line x equals 9. What does that look like?
Parabolic
It's a parabola
with a flat end,
with a flat end. What about that parabola?
9 inches tall.
No.
No? Oh, 9.
Show me what the parabola looks like.
Oh, it's like
No.
that. No?
No.
Oh, it's
Across
that.
No.
It's like side this way.
It's sideways, correct.
All right.
Because x equals 9 is a vertical line.
I see.
So it looks like that red dot. It looks like that.
It's just really tiny. Yeah, if you zoom in.
Right. If I zoomed in, it would look just like that. We're going to stand a rectangle up on that. This one's a little bit easier because I'm not going to change the height of the rectangle. The height of the rectangle is going to stay at 2 units, 2 inches, 2 feet, 2 yards, 2 units, whatever. So when we're done, and again, you don't need to do this, when we're done, we're going to end up with a shape that looks something like this. So there's the parabola, there's a height of 2, and then these rectangles, this represents our rectangle as it slides from 9 back to 0 or from 0 back to 9. When you're doing cross-section problems, you'll actually need 2 diagrams. One of them will be that, what the base looks like. The other one will be what the cross-section looks like. So the cross-section of this is a rectangle. Notice the bold line down at the bottom. The bold line down at the bottom of this matches the bold line in my base. So I know how that stands up. It'll change from problem to problem. So for instance, if I had a 45, 45, 90 triangle, are you standing it up on one of the legs or are you standing it up on the hypotenuse? How are we doing so far? Good. Okay. What's the area of that rectangle? 4 root x. I'm taking rectangles from where to where? 0 to 9. Done. That's it.
It's not. It's gonna be
Of course it's going to get harder. I intentionally started with an easy one. And now, yeah.
Wait, so how did you get the rectangle in a...
Excellent question. So, you're asking where that came from.
I mean, I see that it's the length of it, but aren't they going this way?
They're going this way.
So how do you know what the depth of...
Well, if I go from here up to here, this distance would be top minus bottom. Square root of x minus 0. Right? This distance is twice one of those. So I doubled it to get that entire rectangle length. That gives me the base of the rectangle, and the problem says that the height of the rectangle is always constant. It's going to be 2. So any rectangle from 0 to 9 is going to have a height of 2 sticking up off the board. So then find the area of this rectangle, base times height, 4 times the square root of x. Integrate it from 0 to 9 because we're taking rectangles from 0 all the way over to 9. Debbie?
Wait, why is that point x comes with x? Why isn't it 9?
Because any point on a function is x f of x. Right? And since our function is this, well, it's not a function. It doesn't pass the vertical line test. When you solve this, you get y equals plus or minus square root of x. This one is the positive square root of x. Yeah.
So you just kind of have to pretend that it's a height of 2?
Because you can't see it. It's sticking up off the board.
But like, that height's going to be different than that height, or is that not?
This height is different than this length. Yes.
But like the height over here and the height over here.
Correct. It's going to change. So if I take the rectangle over here, this height is going to be different. This will still be 2. And that's why we get a boring flat shape. It's not real exciting. The next one, more exciting.
Okay.
Okay, then it's going to change. We get something that you want to carve out of wood, not just that thing. Okay? So now we're going to take a circle with a radius of 4 and stand an equilateral triangle up on it. So we're going to find the volume of Alex, hold that one up that you're balancing on there. No, that one. We're going to find the volume of that guy. So show us the base. The base is a circle, and what's standing up on there, or the cross sections, are equilateral triangles.
I have all the toys.
Excellent. Don't break them. They're worth a lot of money.
They are broken.
No, they were designed that way, knucklehead.
Now I have more pieces to play with.
Great. Circle with a radius of 4. What's the equation of a circle with a radius of 4? No, that's the area.
X squared plus y squared equals
X squared plus y squared.
6.
No, 6 isn't it?
Good. Why is that funny? Because we're struggling to remember the equation of the circle?
Because everyone said something different. And you were just like, yeah.
I'm just, okay. Yeah, because all I'm doing is looking for somebody to say the right answer, ignoring all the things like, you know, silly, ridiculous. All right, anyways. I need to know that length. How do I find that length? Where is this point? Demi, I'm going to pick on you because you just asked me a question about it.
Okay.
Where is that point?
X.
Good start.
Or
Ooh.
minus X.
No, you're on the right track. You just did a bad math thing. So tell me how you got 4 minus x. You solved that for y, right?
Yeah.
Oh yeah.
So you got y is equal to 16 minus x squared, square root of that whole thing, and then you did a bad thing. This is not equal to 4 minus x. Don't do that.
Okay.
This good, that bad. So we'll leave it like that. We're good? How long is that then?
Square root of 16 minus x squared.
Wonderful. How long is this?
2 times that.
Well said. Before I move on, is everybody okay with that?
Can you say that again?
Sure. Let's back up. Does everybody understand how Demi got this point?
Yes.
Point on any function is x comma f of x. This is not given in terms of y, so she solved this equation for y, move the x over, take the square root, got that. So that's where that point is. How far is this distance?
Square root of 16 minus x. Oh yeah. X.
Which one?
4? I don't know.
Square root of 16 minus x? Isn't this the y value? Uh-oh. How long is that guy?
Square root of 16 minus x squared.
Let's back up. Do I have a horizontal or a vertical rectangle?
Horizontal.
Therefore? Oh, we're working in y's. Okay, let's start over. Demi, if we're working in terms of y, where's this point? This is going to scramble some of your noodles. Why? No, 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 why?
Well, because I said that.
I understand. Where's the y?
Root 16. Root 16 minus y squared.
Y squared.
And then 1.
Good.
So did we do it wrong?
Hmm?
We did it wrong.
I did it wrong? No, we did it wrong. Well, no, we didn't do it wrong. That's correct. But that's in terms of x.
So we did it wrong.
No, it's not wrong. It's, I mean,
That you raised.
okay, sure, it was wrong. In this particular situation, it was wrong. But it was right, it was just wrong.
Right.
Correct.
I'm glad you recorded this.
How long's that?
Right.
16 minus
minus y squared.
Square root of 16 minus y squared. Which therefore this is 2 times 16. Okay, so good. Now we're making progress in the correct way, even though the other way was correct. This distance, the darkened one in the circle, matches the bolded part on the bottom of this equilateral triangle, which is going to be our cross section. That's why this is 2 times that mess. And I'm sure that your geometry teacher taught you the area of an equilateral triangle, right? You all remember that formula, right? Right? Yep. Yep. No? Not so much, huh? Okay, how about that guy?
Oh gosh.
Yeah, of course, you remember it now.
No.
S squared squared to 3 over 4 is something you want to write down and know. It's an easy way to find the area of any equilateral triangle. S is the side length. Plug and chug and you're done. That's an easier way than finding the base, the height, 1/2 base times height, doing all that fun stuff. Question?
Yeah.
Go.
Why or how can y just why did you flip them?
Because we're in terms.
Because,
It's terms of y, but like
because our rectangle, the indicator there is our rectangle is horizontal. Anytime the rectangle is horizontal, your values or your equations have to be in terms of y. If they're vertical, we could do the same problem in terms of x. We could put them this way, you'd get the same answer, but I want to do it in terms of y because it says perpendicular to the y-axis. So the problem is forcing us to work in terms of y. Yep.
Why isn't the base 4 of the triangle?
The base is 4 of the triangle, Gesundheit. If it's the triangle that happens to be right here, we want a triangle anywhere in this region.
Oh,
So we have to talk in generalities here, not one specific triangle. Taking this information and plugging into there and simplifying, we get that. That's the area of that triangle. Because the square root of anything squared is itself. 2 squared is 4. 4 over 4 is 1. And we get the square root of 3 times the quantity, 16 minus y squared. Where am I taking triangles from? To what? In other words, what are my limits of integration? -4 to 4. Wookie doke.
Wait.
Okay, yeah.
Good.
All right. Okay. So, here you go. How would I simplify that, or how did I simplify that? Did.
sorry,
Let us back up, shall we? Are you okay with this?
yeah.
Squared this. 2 squared is 4. 4 canceled with the 4 on the bottom. Goes away. Square root of anything squared is itself.
Okay.
And then I got that square root of 3 hanging on there just because it wants to be cool.
Thank you.
No problem. You could fn int it. However, some of you have become too dependent on fn int and try to cheat your way through it. So therefore, you should be able to do that by hand, which I did. Plug and chug. Answer. Okay? Draw a picture of your base. Draw a picture of your cross section. Figure out how the cross section ties in with the base. Find the area of the cross section, integrate it for all the possible cross sections. Hair fix or question? Hair fix. Awesome. Are we good? Okay. There's a cross section for you. Get it?